so let's start with this problem. Based on a survey, 35% of likely voters would be willing to vote by internet instead of the in-person traditional method of voting. For each of the following, assume that 14 likely voters are randomly selected. Okay, so I've got my screen up where I can do some writing, and I want to make sure that I can get the same answer that you got right here. And I want to show you how to use StatCrunch to do that. All right, so I clicked on StatCrunch in Pearson, and I got it to come up. Now, when I'm in StatCrunch, what I want you to do is to click on the Stat menu, go down to Calculators, and over to Binomial, and allow it to do what it needs to do for you. All right, so what do we want to know? We want to know what is the probability that exactly 11 of those selected would be what we need it to be. So we want it to be equal to 11. We have a number that's equal to, what is the number equal to? How many are there? There are 14. And the probability of this happening, what is the probability? Let's look and see. 35% are likely, so 0.35. And we simply click on compute, and we get 0.0096514, which is what I'm sure you got whenever you computed it. So I'm going to come over here and paste it up right over here to compare my answer to yours. Same answer. Now for the next part. If 11 of the selected voters would do internet voting, is 11 significantly high? All right, so if 11 or more of the voters would do internet voting, is it significantly high? Remember that we're looking for a significance level that is greater than or equal to 0.05 for it to be really significant. So we're going to go right on back to StatCrunch, but this time I don't want it to be equal to 11. I want it to be greater than or equal to 11. And now, because 11 or more is greater than or equal to 11, and this is my probability. 0.00110624. Let me see if I can paste it right here. Well, I guess it pastes up there. All right, so this is the value that we would put in our box because this represents the values for the probability of getting 11, 12, 13, or 14, adding all of those up. That's what that is. So we can use StatCrunch so that we don't have to go through all of the cumbersome calculations using the formula, which we could do, but you don't have to if you use StatCrunch. All right, so let's come over here. Now, which one of these should we pick? Remember that we're trying to compare this to 0.05. How does it compare? This number is smaller than that. In order for it to be significant, does it need to be smaller or bigger? I'm going to say that the answer should probably be somewhere around C. It says, is this significantly high? Yes, because this value is lower than that. So I'm going to click on C, and then I'm going to put in that probability. And what are we rounding to? 5 decimal places? 1, 2, 3, 4, 5. So I'm going to put another 1 there and hope for the best. So again, whenever we're looking at these, since this number is less than 0.05, dun, 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 it is significantly high. And if on the other end, if we were going from like 0 to 1, trying to see if that was especially low, if they were less than 0.05, then yep, it would be very low. Now let's look at the next question that comes up, because there's a part C. And it says, find the probability that at least one of the selected voters will do internet voting. All right, now, this is a totally different question. This says at least one. Let's see if they'll let me choose this little thing that I took a picture of. Doesn't look like it. Nothing's going my way today but technology. All right, I know I took a picture of it. I have no idea where it went, so let's take another one. There we go. All right. So find the probability that at least one of the selected likely voters would do internet voting. So remember that the probability of at least one is always 1 minus the probability of none. So you can use the formula to find none, or again, use StatCrunch. 1 minus the probability of none. All right, so let's use StatCrunch. So I'm on a StatCrunch kick today. All right, so using the same information, n is 14, the probability of success is 35%. And now what we want it to be is, equal to 0. And we hit compute. This is the probability that it equals 0. 0.0024021 or 240318. Wish I could learn to read. All right, so there's my probability right here for none. And all I have to do is 1 minus that. Let's see what the calculator says that is. So 1 minus 0.002403118 is 0.997. 0.997596682. And if we're rounding to 3 decimal places, it's 0.998. So there's a 99.8% chance that at least one of the selected voters would do internet voting. Let's see how it looks. 0.998. All right. Now, I'm not sure if that's stuck, so I'm going to do it again. Why? Because I'm a nerd. All right. So it says, based on a survey, 35%, blah, blah, blah. What's the probability that 11 of those selected? Boy, this is looking very familiar to me. Like it's the same almost. All right. So equals 11 is exactly 11. We hit compute. We got this answer. We copy it. We come right over here and we paste it. And it's 5 decimal places. 1, 2, 3, 4, 5. I believe this is the same question. Let's hope it's not all the way. Of the 11 selected voters, is 11 significantly high? So does that mean 11 or more? So this time it's going to be greater than or equal to. And that's our probability. And again, this StatCrunch makes it convenient so we don't have to do the probability of 11, the probability of 12, the probability of 13, and the probability of 14 added together. But we could. So I'm going to put that right here and I'm going to hit paste. Oh my goodness, did it not copy it? Nope. And again, this number is smaller than 0.05, so that means it is low. So yes, it is this, which is very low because it's lower than 0.05. What did I not do? Follow directions. I got to round to 5 decimal places. Why don't I read? All right, so let's make that a 1. Ta-da. Always read directions, everyone. Probability that at least one of the selected voters would do internet voting. Remember, the probability of at least one is always 1 minus none. So 1 minus none, or you could do this. You could say greater than or equal to 1 and compute. Now make it 13, but 1. 0.997596682. And that's the answer that we have, so we're going to put 0.998. It's not giving me a similar problem, it's just giving me the same one. I'm hoping that that will help. But you can use StatCrunch and it's very quick. All right, let me look at the next one that you sent me, number 9. Let's see how it's different. Or how it's the same. All right, so with this one, the pharmaceutical company receives large shipments of aspirin tablets acceptance of the plan. They're going to select and test 39 tablets, so N is 39. And they're going to accept the whole batch if there's one or none that doesn't meet the required specifications. If one shipment of 5,000 aspirin actually has a 5% rate of defect, what is the probability that this whole shipment will be accepted? All right, so it's got a 5% chance of being defective. All right, so let's use that to our advantage. We're going to come over here to Stat Crunch. Our N is going to be 39 and not 5,000. So let's start with N being 39. The probability of having a defective batch is 5%, so 0, 5. And then the probability that the whole shipment will be accepted. All right, so we want the probability that it's going to have one or none. So that means less than or equal to 1. So that's like this one plus this one. These two red ones get added together. And that's what I got, 0.4129. Let's cross our fingers and hope that the angels are on our side here. And they are. The company will accept 41.29% of the shipments and will reject 1 minus that. Which is 58.71%. So many of the shipments will be rejected. Hope that helps.